Oh, and we've been at Brackley the last 4 days seeing some amazing things, the cars returning from Monza, and now we're standing in front of this magnificent engine. What are we looking at?
Well, this is one of our current 2017 Formula One race engines. It's GH50, so engine number 50 from this season. And we've recently run this on the dyno and achieved a figure of in excess of 50% brake thermal efficiency. That's something we've been chasing for a little while, and we've achieved it recently.
So you mentioned thermal efficiency. What does that actually mean?
Well, an engine burns fuel, and we use Petronas Primax fuel in our Formula One engines, and most engines will only convert around 30 to 35% of the potential energy that's available in the fuel into useful work or power. With our power unit, we've managed to develop it to generate more than 50% thermal efficiency, which means more than half of the available energy in the fuel is now being used to do useful work. And in fact, we're getting more useful work than we are waste energy for the first time.
That is an incredible achievement. How do you extract that energy from it?
Well, the first thing is the actual internal combustion engine itself. We have to do a lot of work to develop the thermal efficiency of the engine, so a lot of work goes into fundamental thermodynamic principles, the gas exchange processes, the combustion. It's very important. That's very important to extract as much energy as possible from the fuel. Once we've done that, it's about minimizing the losses, so we need low friction. So again, with Petronas, we've developed oils to reduce the losses and the friction, which otherwise would go into waste heat. But once you've done that, there's still a fair amount of energy that still goes into the exhaust, and that's basic principles of thermodynamics. It's not possible to eliminate that completely. But with the turbine and the MGU-H that we're allowed on these engines, we can extract a large proportion of that waste heat and convert it back into mechanical energy. So we have the MGU-H used to extract waste heat from the exhaust, convert it into electrical, and then the electrical energy is sent back to the MGU-K and to the crank. So we have a lot of work on the thermodynamics of the turbine and the compressor, and also the electrical conversion efficiency from the MGU-H to the MGU-K. And without the MGU-H, we would not be able to achieve the 50% figure that we've just achieved.
You said that this engine had been in the dyno, so do you think you could take this engine straight away and put it into an F1 car?
Absolutely. It's built to the same spec as the engines we're currently racing. It's fully compliant with the current FIA regulations, obviously. There's a couple of things on the dyno. For example, we can run the air temperature a little bit cooler. That's something that we wouldn't do in the car because of the aerodynamic penalty, but it's still fully permitted within the rules. And the rules don't permit too many exotic materials, so there's a lot of materials like aluminium and steel, which would just be what you'd find in a normal road car, so there's nothing particularly exotic about it. And we're actually working on a project at the moment with Mercedes-AMG to put a version of this Formula One engine into a road car called Project One, which will be a very exciting road car indeed.
Oh, what an amazing achievement. You must all be really proud.
Yeah, I mean, the 50% thing is a great thing for the company to have achieved, and actually it started with a bit of a challenge from Andy to me. He knew I was going to be 50 soon, and he thought, what will get to 50 first, me or the engine? So we've both got there at the same time, so yeah, that was quite good.
That's great. Thank you very much.